everyone. Today I'm going to be talking about stereochemistry for alkenes. Specifically, an alkene has a double bond. They're consisted of double bonds. So for the stereochemistry of alkenes, it is denoted by the E and Z system. And this system is based on that's used in the same way for assigning configuration to tetrahedral compounds, and they both use the Kohn-Ingold pre-log rules. So let me just note that down. They use the Kohn-Ingold pre-log rules. So, that E looks funny. Okay, pre-log rules. So, a few things to note as I'm talking about how we're assigning configurations at double bonds. So, alkenes, they are sp2 hybridized, and there's a pi bond within this double bond. And pi bonds, they favor a planar arrangement. So as you can see, if you can see here, like I said, it's assigned by E and Z. If you can see here, these structures I have placed down here. So to give a little background on what the Kohn-Ingold pre-log rules, priority rules are, basically we're assigning priority. What's important with assigning E and Z with respect to these configurations at double bonds, we want to look at the priority group. So if you didn't know already, Kohn-Ingold pre-log rules has to do with assigning priority in the order of decreasing atomic number. So we're assigning priority with decreasing atomic number. And if that doesn't work, you look at the other substituents the atom may have, and you compare them till you find a difference. So you look at the second, third, fourth atom till a difference is found. So I'm just jotting it down here as a chart, kind of as a little memo, so we know when we're figuring out throughout these examples if they're E or Z. And I will get to E or Z. And the last rule is that if you have a double bond or a triple bond or double bond, you're going to look at it as you have C triple bonded to A. Think of C is bonded to A 3 times. So it'll be something like this. That's what it means. It means, so pretty much what I'm saying is that multiple bonded atoms are the equivalent to the same number of single bonded atoms. So I can even write that down. Let me move this over here. What this means is that multiple bonded atoms are equivalent to the same number of single bonded atoms. Single bonded atoms. So that's what I'm saying pretty much over here, what's going on. Okay, so the same side, and E means the opposite side. So you have these groups attached to these carbons here. You have a group that's attached here, at this one carbon, and at another carbon, you have these two groups attached here. So they are usually ranked as higher or lower, looking at the molecule. So if the higher ranked groups on each carbon are on the same side of the double bond, the alkene is said to have Z geometry. This is higher priority ranked groups on opposite sides. So this has E geometry. This is the E isomer and this is the Z isomer. So let me note that down. So Z means the higher priority groups of the double bond. And let me move this a little. Okay. And this E just pretty much means that the higher priority is on opposite sides. So I'll just put opposite here. So I wrote the full out here, and this is pretty much self-explanatory. It's the opposite. So this is the same side, this is the opposite side that we have the higher ranked groups on. So this is what Z is that I have down. Okay, now let's jump into some examples, shall we? So the first example I have over here is, I have this example right here, as you can see. So for this one, we're going to apply the rules that I have explained here to this one to see if it's E or Z. So I'm going to split this in half. I'm going to move this actually. Examples we're looking at, right? Now we're going to cut this because we're going to compare this carbon to this carbon, which is higher or lower. So what I like to do first is assign each group if it's higher or lower based on this carbon, which is high at the top, which is low at the bottom. Okay, so as you can see here, we look at the decreasing atomic number. So for this one here, we look at this carbon, this is here, and we look at this hydrogen, and you can see that this carbon has higher priority than this hydrogen. So this will be high. This is a higher priority group here because this carbon has a higher atomic number than this hydrogen. So this is given priority. So this is high, and I will put blue for low. This is low. Okay, now we've done with that. Now let's move on to this side here. Okay, so now we see that. So we see this carbon and this carbon is the same. So now, as I have said back to this rule, look at the second, third, or fourth atom to see if you find a difference. Okay, so we don't see a difference in these two carbons. So we're going to go to the next atom now. Now we have two hydrogens here. Two oxygens here. We have two oxygens here. And in comparison, there's one oxygen and there is a total of 3 hydrogens. So back to this, coming now down to here and to this, so we see a difference. So now we've applied this rule, we see a difference. We see that there's 2 hydrogens, 1 oxygen, and then there's 2 oxygens and 1 hydrogen. Now, going to this rule, if you have a triple or double bond, that means that that carbon, that atom, is going to be bonded to that other atom 3 times. So this carbon bonded to this oxygen it looks like this. So essentially, this is what it's going to look like. This is our carboxylic acid. So this is what it looks like. Now this carbon bonded to this oxygen is bonded 2 times. So essentially, oxygen essentially carbon is bounded to oxygen 3 times, like this. So 1, 2, and 3. So this means that this has a higher priority than in comparison to this one up here. So we're going to label this as having the higher priority and this one as a lower priority, because this follows the rule that I explained over here, how multiple bonded atoms are equivalent to the same number of singly bonded atoms. So this follows this rule over here as I just explained it, because as you can see, if you have a carbon double bonded to A is any atom, it's bonded to that A 3 times. And so this carbon bonded to this oxygen is bonded 2 times. And also it has a little alcohol it's bonded to as well. So it's bonded to 3 oxygen atoms. Now that being said, this has a higher priority than this one. Now what can we designate this as? We're going to designate this, because we have higher priority groups on opposite sides, this is going to have an E configuration. So this is what you would configure this as if you're ever asked this. This is the configuration of this. This is E because it's on opposite sides. Now let's move on to another example I have down here. Let me move this up. I'm going to cut this in half. I'm going to highlight my carbons. We're going to look at one area at a time. So we already know that this has a carbon atom. This is a hydrogen atom. And we are going to assign priority in the order of decreasing atomic number. So we know that this has higher priority than hydrogen because carbon is bigger than hydrogen. So we know this has higher priority. And as for this side here, we can see here's a little different story. Now, you may be thinking, okay, so I see this here, and you're thinking this may have a higher priority than this one up here. You're wrong, because when you expand, now keep in mind, you're looking at, you're comparing carbons, and you're seeing which one is going to have higher priority, right? So, when I'm looking at this carbon, you would skip over to the next atom. Okay, so this carbon here, same. Next atom, you have this carbon, but you have this oxygen here, and this is a higher priority. Now you're like, wait a minute, what about this carboxylic acid group? This is not attached to this carbon. It's attached to this carbon right here. And I can expand this out. So the way this is going to look like is this. So this is the carbon that I'm referring to right here. I can even go back to the color scheme for this. So this carbon here, this carbon, the way it looks like is this. And it's bonded to that green carbon, that's this one here. And it's looking a little bit like this. This is how this carbon here looks that I'm referring to. I'm not talking about this here. Let me just use my laser tail. I'm not talking about this. I'm talking about this. That's what I'm referring to. That's why I'm saying that this has a higher priority than this, because you're looking at this carbon. You're looking at this carbon. You're not looking at this over here. So that's just a little trick that that will help you is, it helps to expand the atom out. And then from there you can compare. So, and we're comparing this carbon to this oxygen. So this oxygen is going to take higher priority over this, whatever carbon here is, that's attached to all of this over here. So this is going to make it a Z isomer, because it's the same side that we have higher priority, higher ranked groups attached to each carbon. And this is the low. And this is low here. So it helps to draw it out. It helps to better. And the way that this one looks here, and I can even also draw it out too, the way this is going to look is like this. And it's attached to OH. And I'm going to even draw that little extra carbon that it's attached to that we've highlighted here, that we have in green right here. So, So, when we're comparing, when we skip this whole atom here, this whole area, this whole carbon atom here, because they look the same, we go to the next one, we can compare the next atom in the group. So we can see that this oxygen has a higher priority than this carbon here. And Z isomer that we have classified this molecule as. Okay, so another example, I have a few more. Another example I have here. If you know your functional groups, and I will have a video on that. So we know CN is usually something looking like this. We know that that's a nitrile, CN. C to N is C triple bonded to N. So this here, as you can see, it's lovely drawing of an alkene. Let's cut it in half and compare groups. So I'm going to cut this and label my carbons. So on this side, on the left side, I can see that it's this hydrogen and this carbon. I'm comparing it. This carbon has a higher priority, so this is higher, and this is lower. Okay, now let's move to the other. The CN has a higher priority. This has a higher priority than this because this carbon, like I said before, is bonded to nitrogen 3 times. That's how you would look at it. And this being bonded to nitrogen 3 times in comparison to this just being bonded to hydrogen, and NH2, this is obviously going to have a higher priority over this. So this is going to be high, and this is going to be low. Oops, it's in the frame. Okay, this is going to be low. So yeah, so once again, this is bonded to nitrogen 3 times, and this is how this carbon here looks like when it's bounded to 2 hydrogen atoms and this amine group. So you can see the difference in priority and how we would classify this as high and this being low. Okay, now it's on opposite sides. So this configuration we will assign as E. This is the E configuration because we have higher priority groups on the opposite sides. I have another example I have written here. Now this is a cyclopentyl group because there's 1, 2, 3, 4, 5 carbons. So this is known as a cyclopentyl group. So with this one, we're going to cut it in half. Carbon, here's another carbon, here's another carbon. Okay, so, I can kind of envision this imaginary line coming down the middle here. And this is really helpful because this is what you're comparing to, carbon to carbon, apples to apples. You're comparing which one has a higher priority, which one has a lower priority, in terms of cyclic compounds. So when you look at it from, I can even just twist it around. When you're looking at it from a certain angle, like this, it's easier to see, and that's the way I like to visualize things. So you can see that this side here has this methyl group in comparison to this side. This side doesn't have a methyl group. So the one having the methyl group has a higher priority, has the highest atomic weight. So this side here is going to have the the higher priority. This is going to be up. This is going to have a higher priority. This is going to have a lower priority because this has no methyl group here. So just switching this back around from that point of view of how you saw it, going back here, we can see that this is going to have a higher priority. So this is higher priority because of that methyl group. This has lower priority. And, you know, it literally just has two hydrogens that are attached. This has a carbon atom here as well, but this has more weight than this, clearly, because it's attached to another carbon. So this is higher priority than this due to its methyl group right here. Now on this side here, we have carboxylic acid, and we have this over here as well. So, like I said before, you know, in the previous example, as I showed you up here, how this one had a higher priority than this one here. Yeah, how this one had a higher priority than this one here. And it's due to the fact that this carbon is double bonded to that oxygen. That means it's going to be bonded to that oxygen 2 times. So coming back to this example here, this carbon atom is singly bonded to oxygen 2 times, as well as this other oxygen attached to this alcohol. So that means it's bonded to oxygen 3 times in comparison to this. And you can already start to compare the differences. So you know that this carbon's the same. Let's go to the next one. So these two that are different. So this oxygen is going to have higher priority over here, over in comparison to this one. So this is high. Oops, wrong color. This is high. And this is low. This would be our Z configuration because you have higher priority groups on the same side of the double bond. High priority groups. See, this is a higher priority group on the same side of this double bond here. So this is a Z configuration because you have higher priority groups on the same side of the double bond. This is an E configuration because you have the higher priority groups on opposite sides here, on opposite sides. And you have, you know, another Z isomer because you have the higher priority groups the same side of the double bond. And here finally, this was our, finally you have E, which is the higher priority groups on the opposite side of the double bond. So I hope you enjoyed this video. I hope it's helped you how to assign stereochemistry for alkenes using the E and Z system. I will have more videos on stereochemistry, functional groups, cycloalkenes, and others. Please like, comment, subscribe, comment any other suggestions on what other kind of videos I should do to help you out, and I hope this video has helped you out.